Today we're going to be talking about the mole. Now before we talk about what the mole is, we need to learn what the mole isn't. So it's not the little rodent that's digging around in your garden, and it's not a spot on somebody's skin. In chemistry, a mole is a unit that we use to talk about or is related to the mass of things. In fact, it actually comes from a Latin word for mass. But let's start with other things like some numbers. When we get really big numbers, what we start doing is we start using words in place of the numbers. So yeah, even though there is a word for 100, we don't often write the word, we write the numbers. But when we get into millions or billions, instead of writing all the zeros that go with all those billions, 8 billion, we actually will often just write the number. And then that allows us, or continues to allow us, to do pieces of, so fractions of, really large numbers. So instead of writing out all of the numbers, I could write 12.5 million and it's still clear what I'm talking about. If we take that back into chemistry, or actually a slightly different direction with chemistry, if I take a look at a molecule that here, so this one, I've got 3 atoms of calcium, 2 total atoms of phosphorus, and 2 times 4, 8 atoms total of oxygen. I would add all those up, and then my molecule then has 13 atoms. If I took 3 molecules, I would have each one with 13 atoms, so 3 times 13, 39 atoms. If I kept that going into lots and lots and bringing in the millions, then I would have 1 million molecules with 13 million atoms, or 3 million molecules with 39 million atoms. Pattern stays the same. If I had a really big number, like a bazillion, whatever that means, the pattern would be the same. I'd have 13 bazillion atoms, and if I had 3 bazillion, then I would have the 39 bazillion atoms. Now that idea is going to come back a little bit later. Okay, but what is the mole? We said what it wasn't. What is it? It's actually a number. It's a word that we use for a number, much like billion is a word for a number, or bazillion is a word for a number, sort of. And it's used by chemists to allow us to count very large numbers of very small things like atoms and molecules. The actual number is that, 6.022 times 10 to the 23 things. So 6.022 times 10 to the 23 atoms, or that many molecules, would be 1 mole of those things. I can also write it as that, as a number that we have, a sextillion, which we don't really care about, or if you really wanted all the zeros, that. If you don't want all the zeros, don't worry about it. How do we use it? Well, 1 mole of iron atoms would be 6.022 times 10 to the 23 atoms of iron. Or 1 mole of water molecules would be 6.022 times 10 to the 23 molecules. And 3 moles of that those water molecules would be 3 times that molecules. Now you might be wondering, how are we going to use that, because it's a really big awkward number. And the good news is we don't. We don't actually use the number 6.022 times 10 to the 23. We use it in the word mole. So that's actually how we do our counting. So we're going to be counting them as groups, as moles of things. So remember that thing about 1 bazillion molecules would have 13 bazillion atoms? Well, I could keep that pattern going, but now talk about 1 mole of those molecules would actually have 13 moles of atoms. Mole is just a number, like bazillion is a number. And that other one that we had, where 3 billion or bazillion molecules, well, if I had 3 moles of those molecules, I'd have 3 times 13, 39 moles of atoms. The pattern stays exactly the same. Okay, if I gave you this and asked you how many eggs there were, and you had to count them up really fast, would you say there were 4 dozen or 48? Did you count them as groups, or did you count them as individuals? We're going to use the mole like the way we use a dozen. We're going to put things into this group, into this bucket that holds a certain number of them, and that is going to be our number. Now, it wouldn't matter if it was a dozen donuts or a dozen eggs. The number is the same. The box that we use is different. Okay, so how do we count with moles? We can't count individual atoms. It's not even possible, and it would take more than a lifetime to do it, so we're going to need something else, and we use something called the molar mass. And the molar mass is the mass of 1 mole. And the unit that we use is grams per mole. That's kind of how we say it, and how we write it is G/mol, grams per mole. And we end up using the mass numbers from the periodic table. So if you look at a periodic table, in each box there are a couple of numbers, and we want the number at the bottom. Let me go back to that. The bottom, that's the mass of the atom. And that is the atomic mass, but it can also be thought of as the molar mass of each atom. So let's try one. If I go to iron, or if you go to iron and have a look at the periodic table, you're going to see a box something like that. It might have a couple more, a couple less decimal places, but the box is going to look more or less like that. The number at the bottom, the 55.8745 rather, that is the molar mass of iron. We could write that as 55.845 grams per mole. Yes, we can talk about rounding off, but not just yet. If I asked instead for potassium, you would find potassium on the periodic table, and you would find the box and look at the numbers in it, and you would find that the number at the bottom, the mass number for potassium, is 39.0983. Yes, you could round off a little bit. And that would be, in grams per mole, the molar mass of potassium. So when I start putting atoms together to form molecules, or moles of molecules, like this one, CH3OH, I'm going to need the boxes for carbon, hydrogen, and oxygen. And I've got 1 carbon, and the mass for it is roughly 12. I have 4 total hydrogens where the mass is roughly 1, and 1 oxygen where the mass is roughly 16. Add them all up, and I have a mass of 32 grams per mole. Doesn't matter if it's an atom or a molecule, grams per mole. And if I had this one, Mg, so magnesium, S, sulfur, O, oxygen, SO4, I need the 3 boxes for magnesium, sulfur, and oxygen. I take their numbers and I round it off a bit, but not as much as what you might think we can. I don't want to do too much rounding, but 24.3 for magnesium, 32 for sulfur, and 4 times 16 for oxygen gives me a molar mass of 120.3 grams per mole. And that's all there is to it. Now, we don't only ever use a single mole, right? We sometimes have more or less. So we're going to take that formula that we just got finished doing with the carbon, the hydrogen, and oxygen. We know its molar mass. Okay, what if I wanted the mass of 2.5 moles? Well, what I would do is I would take the mass of 1 mole and multiply it by 2.5. How many moles do I have? So if the mass of 1 mole is 32 and I want 2.5 of those, I multiply them together and I get, 80 grams for whatever that number is, grams as the mass of 2.5 moles of that stuff. And if I took the other one with magnesium and sulfur and oxygen, which was 120.3, and if I wanted less than 1 mole, 0.63 moles, well, I'm going to do exactly the same thing. How heavy is 1 mole, and then how many moles do I have? Well, I've got 0.63 of them, and I'm going to multiply by 120.3 because that's the mass of 1. And I would get, this number here is 75.8 grams. So what we need to know is that when I want the mass, I'm going to take the number of moles that I have and multiply by the molar mass. So now I know how to calculate numbers of moles, and I know how to calculate molar mass, kind of the other way around though. Okay? And then we're going to use that as a formula in this form. Mass equals N for number of moles times molar mass. Okay, sometimes I have a mass and I want to know how many moles that is. How many groups do I have? So if I were to do the same kind of thing using the same things that I had before, how many moles if I had 37.5 grams? Well, now I know the mass of 1 mole, and I know the mass, I know the numbers of moles that I have. I know the mass that I have. How many moles are there? Well, now I'm going to take the total mass that I have, and I'm going to divide that by the mass of each mole. So the number of moles is the total mass divided by the mass of each mole. And that's going to give me numerically 37.5 divided by 120.3, which works out to about 0.31 moles. And the unit for moles is that, MOL, don't shorten it any more than that. That is the standard unit that we use. Now, that doesn't seem quite as natural, but if we think about eggs for, again, if eggs are $4.75 a dozen, and I know that they're not, but if I had $13.62, how many dozen eggs could I buy? Well, what I would do is I would take the total amount of money that I have available to me, 0.62, and divide it by how many, the cost of each dozen, and I would get that number. Now, I know you can't actually buy eggs that way, probably, but if I could, that's what I would do. That's how many dozen eggs I could get. The same thing is going to be for numbers of moles. It's going to take the total mass that I have available, and I'm going to divide it by the mass of each mole, and that will turn into, how many moles I have, the number of moles. As a formula, I want the bottom one here. N for number of moles is the mass divided by the molar mass. Now I can actually work that into an equation triangle, and you may have seen these before, you may not have. We'll talk another time about how these things work, but effectively what you do is that equation triangle generates for you those other two formulas, or the formulas for that. However, the ones that I had previously were number of moles is mass over molar mass, and mass is number of moles times molar mass. That's what you get out of the triangle. Okay, I want to leave you some to try. I want you to do the calculations on your own. We'll take up answers another time, but it's really, really super important for you to be able to work with this. It's fundamental to almost everything we do in chemistry. So at this point, by the time we're done, we should be able to calculate number of moles. If I have a formula, I'll also have to calculate molar mass, and I should be able to calculate mass if I have a formula and a number of moles. And we'll talk to you another time.